Is it possible for machines to think and learn like humans? This question has been the driving force behind the evolution of artificial intelligence and machine learning. Our journey begins in the mid-20th century, in the year 1956 at the Dartmouth Conference. This gathering of minds, brimming with curiosity and ambition, marked the birth of artificial intelligence as a field of study. The attendees of this conference were pioneers embarking on a quest to unravel the mysteries of the human mind and replicate its processes within machines. Their vision was to construct complex systems capable of mimicking human intelligence, an endeavor that led to the creation of the first AI programs, the logic theorist and the general problem solver. These programs were groundbreaking, able to solve mathematical problems and puzzles, emulating the logical reasoning of humans. But the path to progress is seldom straight. The initial excitement and optimism surrounding AI were met with the harsh realities of technological limitations and dwindling funding. This period, known as the AI winter, spanned the 1970s and 80s and saw a significant slowdown in AI research and development. The dreams of the Dartmouth Conference seemed overly ambitious, as the complexity of human cognition proved challenging to replicate within the confines of available technology. Yet, even in the face of these obstacles, the spirit of exploration and discovery endured. Researchers continued to probe the intricacies of the human mind and the possibilities of machine intelligence. This period of struggle was not in vain, for it laid the groundwork for future advancements, teaching invaluable lessons about the nature of intelligence and the intricacies of technology. The dawn of AI was a time of exploration, discovery, and challenges, setting the stage for the advancements to come. As we moved into the 21st century, technology advanced and data became abundant, paving the way for the rise of machine learning. Stepping into the 90s and early 2000s, we began to see a significant shift. The development of machine learning algorithms during this period was nothing short of revolutionary. These algorithms were designed to analyze, interpret, and learn from massive amounts of data. Previously, computational power was a limiting factor, but as technology advanced, we saw the rise of more powerful computers. This increase in computational power was a game changer. It allowed us to process larger data sets and more complex algorithms, accelerating the development of machine learning. Data, the lifeblood of machine learning, became increasingly available. The explosion of the internet and digital technology meant data was being generated at an unprecedented rate. Everything from our online shopping habits to the photos we shared on social media became valuable data points. This abundance of data was the fuel that machine learning needed to grow and evolve. So, what did this mean for us? Well, it led to the creation of applications that seemed like science fiction not too long ago. Machine learning became the backbone of modern applications such as recommendation systems, speech recognition, and image recognition. Think about it. When you shop online, it's machine learning algorithms that suggest products you might like based on your past behavior. When you ask your smart speaker a question, it's machine learning that helps it understand your voice and respond accurately. When you unlock your phone with your face, it's machine learning that recognizes you. These applications have transformed our day-to-day lives, making technology more personalized and intuitive. They've changed how we shop, how we communicate, even how we unlock our phones. Machine learning has propelled us into an era where machines can learn from experience, changing the way we interact with technology. We're now in an age where machines can learn and adapt, where they can improve from experience. This is only the beginning, and the potential for what machine learning can achieve is limitless. Deep learning, a subset of machine learning, has taken AI to new heights, allowing machines to mimic the human brain more closely than ever before. Let's dive into the concept of neural networks first, shall we? Imagine the human brain and how it processes information. It's a complex network of neurons, right? Well, the same principle applies to neural networks in artificial intelligence. They are a series of algorithms that mirror the operations of a human brain to recognize patterns. They interpret sensory data through a kind of machine perception, labeling or clustering raw input. But then, how did we get from simple neural networks to deep learning? That's where the 2010s come into play. This decade saw a significant leap in the development of deep learning. The term deep in deep learning refers to the number of layers through which the data is transformed. Deep learning algorithms use a long chain of transformations, each building upon the last, hence they are deep. Deep learning's impact is far-reaching and has been instrumental in advancements that we now take for granted. Let's take self-driving cars, for example. These marvels of modern technology use deep learning to recognize traffic signs, pedestrians, and other vehicles. And what about your virtual assistant that wakes you up in the morning or reminds you of your meetings? That's natural language processing at work. Another field that has been revolutionized by deep learning. It's the reason why machines can understand and respond to human language with such accuracy. Then we have computer vision, which is how machines can interpret and understand visual data from the real world. It's the technology behind the face recognition feature on your smartphone, or the automatic tagging of your photos on social media platforms. Deep learning has brought us closer to creating machines that can truly understand and interact with the world around them. In the grand scheme of things, we're just scratching the surface of what's possible. The era of deep learning is indeed a fascinating time in the evolution of artificial intelligence. As we stand on the cusp of a new era, what does the future hold for AI and machine learning? In the coming years, we can anticipate an acceleration in the evolution of these technologies, propelling us into a world where machines can think, learn, and even comprehend human language with an unprecedented level of sophistication. The boundaries of what is possible are being pushed, and we're on the brink of witnessing some truly groundbreaking advancements. One such development is general AI. Unlike narrow AI, which is designed to perform specific tasks, general AI, or artificial general intelligence, AGI, possesses the capacity to understand, learn, and apply knowledge across a wide range of tasks. Imagine a world where machines are not just tools, but intelligent entities capable of outperforming humans at most economically valuable work. That's the promise of general AI. In tandem with this, we can expect significant advancements in natural language processing. This means machines will become even better at understanding and generating human language. They'll be able to comprehend context, sarcasm, and even emotions, bringing human-machine interaction to a level we've only seen in science fiction. Machine learning algorithms, too, will become more sophisticated. They'll learn from less data, make fewer mistakes, and even be able to explain their reasoning. This will not only make them more efficient, but also more trustworthy, addressing one of the major concerns around AI today. When we look at the potential impact of these advancements, it's clear that no sector will remain untouched. In healthcare, AI could lead to early and accurate diagnoses, personalized treatment plans, and even robotic surgeries. In transportation, we could see fully autonomous vehicles becoming the norm. In education, AI could provide personalized learning experiences, adapting to each student's needs and pace. The future of AI and machine learning is exciting and full of possibilities. As these technologies continue to evolve, they have the potential to change the world in ways we can't even imagine. The impact of AI and machine learning on our world is immense and far-reaching. These technologies are reshaping the way we live and work, creating new opportunities but also posing significant challenges. In the realm of employment, AI and machine learning are automating tasks and improving efficiency, yet they also threaten to displace jobs. Privacy, too, is being redefined as these technologies can process and analyze vast amounts of data, raising concerns about surveillance and data misuse. Moreover, AI and machine learning are increasingly involved in decision-making processes. From healthcare diagnoses to financial investments, these systems can make complex decisions faster and more accurately than humans. However, with these benefits come ethical considerations. Who is responsible when an AI makes a mistake? How do we ensure fairness and transparency? As we move forward into this new era, it's important to remember that with great power comes great responsibility. The future of AI and machine learning is in our hands.